Okay, let's do this contingency table problem. Pause the video and read the question here. Okay, hopefully you've done that. So here is our contingency table. Question A, we want to find the marginal distribution of blood pressure level. So our marginals, remember, exist on the margins. We want to expand out our table here and find the totals along each row and along each column. So technically these are our marginals here, but I went ahead and did the relative marginals. So we're going to divide everything here, every single number, by the total number in the table, 474, and get all these percentages. So over here on the side, these percentages are our marginal distribution for blood pressure level. So 20% of everyone, because I divided by the table total, had low blood pressure, 48.9% had normal, and 31% of everyone of the 474 had high. And again, I got that by taking the total number of high, 147, which I got by adding this row, divided by 474. Okay, question B. We want to find the conditionals. Conditionals means you're either doing a row table or a column table, and we're doing a conditional distribution from each group by blood pressure. So we're going to do our column table. So I'm now taking this original table and dividing every entry by the total at the bottom of that column. So for my first entry, I'm going to do 27 divided by the total number of under 30s, 98, and get 27.6%. 48 divided by 98, 23 divided by 98, and so forth. Move on to the next column. Take every number and divide by the column total. We're doing a column percentage table here. And do that for each column. So this number right here, for example, remember whatever comes after the word of, because we're doing a column table, is the name of the column. So 50% of the 30 to 49 age group have normal blood pressure. 37.1% of the over 50 have high blood pressure, and so forth. So we take each number and divide by the total at the bottom of that column, and then when we say our sentence, whatever comes after the word is the name of the column. Okay, part C, we want to compare these distributions in a segmented bar graph. So I have built here a segmented bar graph. So these are by columns. So here's what we had for the under 30s. We could see about a little over 25% of them had low blood pressure. I think it was about 50%. We just stacked those on top of each other. This is also called a side-by-side stacked bar graph. And roughly 24% or so had high blood pressure. So I'm taking these percentages here and stacking them on top of each other. Do that for each group. There's our segmented bar graph. Okay, then question D says, write a description of the association between age and blood pressure. So we want to know, do we see some kind of pattern? Can we make predictions? Can we prove that people's blood pressure will increase as they age? Remember, we can't look at whole numbers here because not all the groups were the same size. So we want to look at percentages. So we could see here, look, in the under 30, roughly a third of them, or over a quarter, 27% had low. Only 15% of the over 50s had low blood pressure. Roughly all groups had about 50% normal blood pressure. Then when we get to the high blood pressure, the under 30s, only 23.5% of them had high blood pressure, but a whopping 37% of the over 50s had high blood pressure. So it seems like as we get older, we get a higher percentage of high blood pressure and a lower percentage of low blood pressure. Kind of interesting that the normal blood pressure stayed roughly the same. It's about 50% of each group. So I would say the data suggests that blood pressure might increase with age. Normal blood pressure does seem to be independent of age. All the groups had about 50% with normal blood pressure. But always remember, correlation does not imply causation. Any question that says, did you prove such and such? The answer is always no. We don't prove stuff in science. We find evidence to back up a hypothesis or reject a hypothesis. We have not proven anything. We've just found evidence to suggest it might.